Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the preparation of alcohols. So there are raw material students from where we are going to prepare alcohols. The first raw material students that we are going to take, that is from alkyl halide. Alkyl, R stands for alkyl and X stands for halide. So students, we are going to prepare alcohol from alkyl halide. When alkyl halide, in short we are saying RX, is boiled with aqueous NaOH. So students, when we are dissolving NaOH in water, we call it as aqueous NaOH, or you can use aqueous KOH, and then alcohol is obtained. So this way students, we can prepare the alcohols. Raw material that we are showing with RX, R stands for alkyl, X stands for halide. React with aqueous NaOH and just boil, or you can say just heat it. So what happens students, the OH of this NaOH react with alkyl halide of R, and it will form ROH, that is alkyl alcohol. Okay students, so alkyl halide is converted into alkyl alcohol, and what happens when the sodium of NaOH now react with halide. This sodium react with halide and it will form sodium halide. So this is general reaction students. Similarly students, suppose you don't have NaOH, you can use KOH also. So students, same way you can also write alkyl halide react with KOH, and that is aqueous KOH, and just boil and heat it, you will get alcohol, and now here K combines with X and form KX. Say for example students, in the board exam students, sometimes they may ask action of aqueous KOH on alkyl halide. So you have to write this reaction. If they will ask in board examinations action of aqueous NaOH on alkyl halide, so this reaction you have to write. Okay students, now one example I am taking students. Suppose you have alkyl halide, say for example C2H5Br, that is ethyl bromide. Action of aqueous KOH on ethyl bromide, so you will write like this. This is aqueous KOH, and just boil it and heat it. So what happens students, this ethyl of ethyl bromide react with alcohol KOH of potassium hydroxide, and it will gives you C2H5OH, and you will get KBr as a byproduct. Okay students, so this reaction is very important students. So you have converted into ethyl alcohol. So in board examination, sometimes they may ask prepare ethyl alcohol from ethyl bromide, so you have to use aqueous KOH. So this way you can prepare ethyl alcohol. When alkyl halide, again students, when alkyl halide, when heated with moist silver oxide, undergoes hydrolysis and forms alcohol. So when you are talking about students moist silver oxide, that means that is nothing but, what happens students, what stands for moist? Moist stands for water. When silver oxide, this is silver oxide, when react with moist means water H2O, it will produce silver hydroxide AgOH. Okay students, so it will produce two molecules, because here silver is 2, so 2 molecule of silver hydroxide you are getting. So moist silver oxide is nothing but, now we are talking about silver hydroxide. So now students, action of silver hydroxide on alkyl halide, understanding students, that we are going to take. So what happens students, this is general reaction students. Alkyl halide is there, when react with silver hydroxide, just heat it students. What happens, this OH of silver hydroxide react with alkyl of alkyl halide, and it will produce alcohol, alkyl alcohol, and you are getting silver halide as a byproduct. Say for example students, when ethyl bromide, this is ethyl bromide, when react with silver, moist silver oxide is nothing but silver hydroxide AgOH. Just heat it, this is moist silver oxide Ag2O, and just heat it. You, what happens students, it will gives here the ethyl of ethyl bromide react with hydroxide of silver hydroxide, and it will gives you C2H5OH, that is ethyl alcohol, and there is a formation of silver bromide. Okay students, these are very important reactions students. In board examination, they may ask action of moist silver oxide on ethyl bromide. This which type of alkyl students, it may be primary, secondary, tertiary. So here I have taken only primary alkyl halide. So ethyl bromide students, action of silver or moist silver oxide on ethyl bromide, which will provide you. So students, how you will get ethyl alcohol from ethyl bromide? So you have to add silver hydroxide. Moist silver oxide is nothing but silver hydroxide. So this way students, in the examination for 2 marks, they may ask in board examination. So this way you have to represent the answer. Second raw material that we are going to use to prepare alcohol is catalyzed hydration of alkenes. Acid catalyzed hydration. Hydration means what? Water. Now here acid stands, we have to add some sulfuric acid. So acid catalyze hydration of alkenes. Alkenes, you know, carbon-carbon double bond. Hydrocarbons containing carbon-carbon double bond. So students, from acid catalyze hydration of alkenes. So second raw material here we are going to use, that is alkene. Alkene. What happens, students? The addition of water molecules across the double bond because alkene containing carbon-carbon double bond in alkene is called hydration of alkenes. Hydration of alkene is nothing but addition of water molecules, that is H2O, across the double bond in a alkene is called hydration of alkenes, or you can say olefin. Understanding, students? Alkene is also called as what? Olefins. So these are the name of alkenes. In common name we also called as olefins. In concentrated, I have used, students, acid catalyzed. So in presence of sulfuric acid, that is acidic medium is required, then only the hydrolysis will take place. Okay, students. So how you write, students? Suppose you have alkenes. In example, students, carbon-carbon double bond. This is alkene, students. In general, you can take any alkenes, students. Here I have taken general reaction. So this is the alkene. The symmetrical alkene I have taken, students. When react with water, H2O. Now water should be acid, so you have to write concentrated sulfuric acid like this. On this arrow you have to write. So this water we call as acidic water. Okay, students. So acidic water, when you add acid, students, it will like this water. You can also write like this. Now you will get hydroxyl group. Now this, and here you will find hydrogen. These two are going to be react with these alkenes. So carbon-carbon double bond now becomes single bond. So now this carbon-carbon double bond becomes single bond like this. Okay, students. Now what happens, students? One of the hydrogen will go to this, another hydroxyl will go like this. Okay, students. So in short way, students, you can also write like this. So your product will be RCH2. So one hydrogen from here, one hydrogen CH2, CHOH, and you are getting like this. This is the alcohol. This is the alcohol. Now you have got the alcohol. So from alkene, students, this reaction, any alkene you can convert into alcohol. So if you have raw material as a alkene, you can convert into alcohol. Understanding this way, students? From acid catalyzed hydration of alkenes, you can convert any alkene into alcohols. Mind well, students, you have to use concentrated sulfuric acid as a acidic medium. So alkene will, this double bond will become single bond, and there will be addition reaction will take place. Okay, students? This hydroxyl, so we call as addition reaction. So this molecule is added, water molecule is added to this alkene. That is why it is called as what? Addition reaction. This way, students, we have prepared alcohol from alkenes. Third way is we are going to prepare alcohol is from hydroboration or oxidation. Using hydroboration or oxidation of alkenes. You have alkene, students. When diborane is treated with alkene in presence of tetrahydrofuran, students, very important, students, this reagent should be there, students, then only you can convert diborane into what? You will convert in primary alcohol. Now, students, when diborane is treated with alkene in the presence of tetrahydroboron, T, and this is H, and this is what F. So in short way, students, we can say THF. So tetrahydrofuran, sorry, this is furan. F stands for furan. So tetrahydrofuran is nothing but THF solvent. In presence of this solvent, an addition product trialkyl borane is formed. When trialkyl borane is then oxidized with alkaline peroxide, forms primary alcohol. So students, so with the help of the hydroboration oxidation of alkenes, so when diborane is treated with alkene in presence of tetrahydrofuran, so as a solvent, an addition product trialkyl borane is formed. So here, students, here there is a formation of trialkyl borane. There will be 3 alkyl group which are added to the borane is formed. Trialkyl borane is then oxidized with alkaline peroxide, form primary alcohols. Here, students, we are talking about alkenes. Alkene is your raw material, students. So what is how you are going to write alkene, students? Carbon-carbon, there is a carbon-carbon double bond. So in general reaction, students, I am writing. So this is alkene containing carbon-carbon double bond. Okay, students, this is alkene. What happens, students? This alkene first is treated with, when diborane is treated with, this is boron, students, BH3. This is boron, but here word is diborane. This is borane, students, but here we are using 2 borane. So it is called as what? Diborane. When this diborane is treated with alkene, this is alkene, students. In general, students, I have taken. In general, alkene is there, students. Now what happens, students? This diborane react with alkene in presence of solvent, students. They have given the solvent name is THF. THF solvent is very important, students. In presence of this solvent only these two molecules will react. So THF is very important when alkene is react with diborane. Why it is diborane, students? This is nothing but BS3 twice. There will be two borane molecule, that is why it is called as diborane. Understanding, students? So this is a formula, students. Sometimes you will write B2S6 also. This is nothing but BS3 twice is not B2S6. So it is containing two borane, that is we call as diborane. So this diborane react with alkenes in presence of solvent tetrahydrofuran. There is a formation of addition product. When the addition product, students, will form, students, addition with trialkyl borane is formed. Trialkyl. There is a formation of trialkyl. So what happens, students? Since there will be addition reaction, when it will happen, students, the double bond will become single bond. So when there is addition reaction, students, your reactant, that is alkene containing carbon-carbon double bond, will become carbon-carbon single bond, and there is a formation of trialkyl borane. So students, this is the alkene. Now it is becoming trialkyl. Your alkene is becoming trialkyl. So there is a formation of thrice. One alkene is converted into trialkyl borane because borane is containing valency is 3. There is a formation of trialkyl borane. Since here we have two boron atoms, so it will form two molecules of trialkyl borane. Understanding, students? So B2. So this way, students, now you have to balance the valency because there is a formation of trialkyl borane from diborane. It is a two borane, so we have to make it thrice. Okay, students. So this 3 2s are 6. So here there will be six molecules of alkene you have to take. How it is coming, students? 3 2s are 6. That means 6 molecule of alkene react with diborane in presence of THF, and it will gives you two molecules of trialkyl borane. Now this trialkyl borane, students, now it will react with alkaline peroxide. This oxygen when this is peroxide, students. Peroxide. This is alkaline. One of the OH will react and it will form the alcohol like this. And there is a formation of boron trihydroxide. So this way, students, you can prepare the primary alcohols. The only primary alcohol you can prepare with the help of these reaction, students. So six molecules of alkene react with diborane in presence of solvent, that is tetrahydrofuran. It will gives you two molecules of trialkyl borane. These two molecules of trialkyl borane react with hydrogen peroxide. Okay, students, this is hydrogen peroxide and forms primary alcohol. This is primary alcohol. See, for example, students, this is the propane, students. When react with diborane B2S6 in presence of solvent THF, tetrahydrofuran, it will gives you directly. Now, students, I am writing. It will gives you tripropyl borane. It will gives you carbon-carbon single bond. It will become single bond, students. One bond now it will combines with borane, one of the borane. Okay, students. Now there is a formation of. Now fill the valency, students, with. So CH3. This is CH2. This is tripropyl borane. How many molecules, students? Since there is a two borane atom, so you have to make it twice. Now how many propane? Now it will be required, students. 3 2s are 6. So 6 molecules of propane now react with one molecule of diborane. This is diborane, students. Borane containing two atom of borane, that is diborane. So propane, 6 molecules of propane react with one molecule of diborane. It will gives you tripropyl borane, 2 molecules. Out of these 2 molecules, students, now we are going to take one molecule. Out of these 2 molecules, now in second step, students. In second step, what happens? This is the first step, students. First step, you have prepared tripropyl borane. Now out of these 2 molecules, one molecule I am taking, students. One molecule of tripropyl borane. So tripropyl, out of these, students, tripropyl, but this is tripropyl bromine. One molecule now react with 3 molecules of hydrogen peroxide, and it will produce 3 molecules of propyl alcohol. Okay, students. This is propyl alcohol, students. Fill the valency with hydrogen. Okay, students. 3 molecules of propyl alcohol will form, and there is a formation of boron trihydroxide. Boron hydroxide, you can say, or it is 3 hydroxide is there, so you can also say boron trihydroxide or boron hydroxide you are getting. So, students, there is a formation of propyl alcohol. Okay, students. So this is tripropyl borane. 1 molecules of tripropyl borane react with 3 molecules of H2O2 gives you 3 molecules of propyl alcohols and 1 molecules of boron hydroxide. Second example, students, hydroboration, students. Now action of diborane on ethene, students, in examination sometime they may ask. So how you will write, students? This is, you have to write the formula first. Why it is diborane? Because there is a 2 boron atom are present, so we call it as diborane. Diborane now react with ethene. In presence of solvent, you have to write, students, this reaction will always take place in trihydrofuran as a solvent, students. There is a formation of triethyl. So what happens when there is an addition reaction? Carbon-carbon double bond becomes single bond. It will combine with one of the boron. Boron is valency 3, that is why it is combining with always 3 molecules of ethene. Okay, students, there is a formation of, because you have used 2 boron. If you want to make 2 boron here, you have to make it twice. Now what about ethene? Now, students, it will become 3 2 6, that is 6 molecule of ethene react with 1 molecule of diborane. In presence of solvent THF, it will gives you 2 molecules of triethyl borane. I am writing only 1 molecule, students. In second step, students, 1 molecules of triethyl borane react with 3 molecules of H2O2 hydrogen peroxide. Understanding, students? That is nothing but these 3 will combine with these 3. It will gives you 3 molecules of ethyl alcohol, and there is a formation of 1 molecules. See, this 1 boron react with 3 OH, boron trihydroxide. Triethyl borane react with H2O2 gives you ethyl alcohol and boron hydroxide. This way, students, you have prepared primary alcohol from alkene, that is ethene. You can write in 2 steps, students. This is first step and this is your second step. So in first step, students, there is a formation of 2 molecules of triethyl borane. Now out of these 2 molecules, I have taken only 1 molecules, which combines with 3 molecules of H2O2 gives you 3 molecules of alcohol and boron hydroxide. Okay, students, this way, students, in board examination you have to write, we are going to prepare the alcohol from reduction of carbonyl compound. We are going to prepare alcohol from reduction of carbonyl compound. From reduction of aldehyde, now carbonyl compound is containing compound is called as aldehydes or ketones. So students, first reduction that we are going to see, that is reduction from aldehydes and ketone. So first, students, we are going to see the reduction of aldehyde. Aldehyde on reduction by hydrogen in presence of nickel, or you can say lithium aluminum hydride. This is lithium. Li stands for lithium, Al stands for aluminum, and there is a 4 hydrogen we call as trihydride, lithium aluminum hydride. Understanding, students? So the molecule is lithium aluminum hydride, or you can say hydrogen in presence of nickel. This is how you are going to read it, students. Hydrogen in presence of nickel. You have to heat the water in presence of nickel, you will find the hydrogen. So now, students, you have aldehyde on reduction by hydrogen gives you, it will always provide you primary alcohols, first degree alcohol. If you want to prepare from aldehyde, so you have to use hydrogen gas in presence of nickel or lithium aluminum hydride. Aldehyde, how you are writing, students? This is the formula of aldehyde. This aldehyde carbonyl, this is carbonyl. Okay, students, this is the carbonyl containing carbonyl groups, carbon oxygen we call as carbonyl group, and this carbonyl group is present in aldehyde. This hydrogen, out of these 2 valency, 1 valency is hydrogen, other valency by alkyl. So this group is always present at the terminal, so we call as aldehyde, students. This is carbonyl compound, but there is a hydrogen, 1 valency is occupied by hydrogen, so we call as aldehyde. Now what happens, students? This, if you want to reduce, reduction means you have to add the hydrogen. Okay, students. Now if you add the hydrogen gas in presence of nickel, students, suppose you don't have nickel, you can also use palladium metal also, and just heat it. So what happens? The hydrogen will now combine. There is addition reaction. Again, students, the hydrogen will, here the carbonyl containing carbon oxygen double bond become carbon oxygen single bond. Okay, students, this hydrogen, now it will come here, 2 hydrogen, 1 hydrogen from here, already it is there, so 1 will be coming here. So there is addition. This is called as primary alcohol. There is a formation of primary alcohols, or you can say this is CH2 and this is what? OH. So this way also you can represent, students. So this aldehyde is now we have converted to first degree alcohol. It is what? First degree alcohol. First degree alcohol. Now, students, suppose instead of this you can use a catalyst like lithium aluminum hydride in presence of acidic water, students, what happens, students? It will provide hydrogen. Again, these students, this aldehyde will convert into carbon carbon double bond is becoming single bond. Students, it will produce the hydrogen. Now this will gives you again a compound that is called as primary alcohol. This is nothing but, you can also say, RCH2OH. So this way, students, you can prepare primary alcohol, first degree alcohol, from aldehyde by two method, by passing hydrogen gas in presence of nickel or palladium, or if you don't have this, you can use lithium aluminum hydride in acidic medium. So this way, students, you can prepare, this is reduction, students. This reaction is what? Reduction. There is a addition of hydrogen to this aldehyde molecule is called as what? Reduction. So aldehyde on reduction with gives you primary alcohol. Example, students, for example, if you want to reduce any aldehyde, suppose here, students, I am taking simple aldehyde like acetaldehyde. If you want to reduce this aldehyde, you can use, in examination sometimes they may ask action of hydrogen gas in presence of nickel or palladium. So this way, students, you can write and just hit it. What happens, students? The formation of CH3, this single bond will become, it will become CH2 single bond, students. Now this addition reaction will take place, so it will convert into ethyl alcohol. Suppose action of lithium aluminum hydride, action of lithium aluminum hydride on acetaldehyde. So again, students, you are getting same molecule, that is, so this is CH2 and your OH I have written like this. So there is a formation, or you can say also write like this, C, the primary alcohol, students. So this way acetaldehyde is converted into primary alcohol. Ketones on reduction with hydrogen gas in presence of nickel or lithium aluminum hydride gives secondary alcohols. Now here is a formation of secondary alcohols. If you want to form the secondary alcohol, students, you have to use ketone. In general, students, ketone formula is carbonyl group. This is carbonyl compound. Ketone is because it is containing carbonyl group. Both the valencies is occupied by alkyl group. So this is the ketone. When reduced, students, when reduced in presence of hydrogen gas, you are passing presence of nickel and palladium metal. Just heat it. What happens, students? This carbon carbon double bond becomes single bond. Okay, students, this way, students, it is becoming single bond. One of the hydrogen will combine like this, second hydrogen will come on here. Now it is nothing but there is a formation of secondary alcohol. Okay, students, this is the second degree alcohol, which is attached to the second degree carbon, so we call as what? Second degree alcohol. This way, students, you have prepared the alcohol, but it is a secondary alcohol, students. Same way, students, action of lithium aluminum hydride in presence of acidic water. Acidic water, we are adding S3O plus. This is reaction to carbon carbon. This carbonyl, there is addition of hydrogen. So what happens, students? Here again, students, carbon carbon double bond will become single bond. Alkyl group like this. Oxygen. Now two hydrogen, one hydrogen will come here, other will here, and it will form secondary alcohol. It is attached to the secondary. So there is a formation of second degree alcohols. In the both case, you can prepare the secondary. So ketone always gives you secondary alcohol. Acetone is well important ketone. Now this ketone, when react, students, in presence of hydrogen gas, you are passing presence of nickel and palladium metals and just heat it. So here again, students, carbon carbon double bond, carbonyl group will now going to reduce. There is a single bond, students, methyl will be like this. Now hydrogen, oxygen, now hydrogen will combine, it will form hydroxyl, and here will be the, so there is a formation of second degree alcohol. So this is the second degree alcohol, students. Same way, students, if you pass lithium aluminum hydride in presence of acidic water, again, students, it will form the second alcohol. Carbon carbon will become single bond, students. So this way, students, you have prepared the, students, that is called as secondary alcohol. Here the secondary alcohol will be isopropyl alcohol, or you can say longest chain is what? 3 carbon. So you can say propane 2OL. Now from the reduction of carboxylic acid and ester. From reduction of carboxylic acid and ester. When carboxylic acids are reduced in presence of lithium aluminum hydroxide, followed by their acid hydrolysis, it will provide primary alcohols. Okay, students. So this is carboxylic acid is also a type of carbonyl compound. So carboxylic acid we are representing, students. This is carbonyl compound only. Okay. Now one valency by hydroxyl, other by alkyl. So this is the carbonyl, students. This carbonyl now going to be reduced by adding lithium aluminum hydride in presence of acidic water, students. So what happens, students? The carbonyl group now reduce, it will form, since two hydroxyl groups are attached, So this is unstable, and on reduction it will gives you alcohol. This is the primary alcohol. So students, from reduction of carboxylic acid and ester, so I have shown the carboxylic acid. So this way students, carboxylic acid will always gives you primary alcohols. When ester, students, second carbonyl group is ester. Ester on reduce in presence of lithium aluminum hydride and followed by their acidic hydrolysis gives primary alcohols. Here also students, ester will always gives you primary alcohols. Now what happens students, here simple example I am taking the ester molecule students. This is your ester students. Ester you can also show like this. Carbonyl, this is carbonyl, here one is alkoxy group, other is by alkyl group. So this is ester students. This ester that we are going to show like this students. COOR dash now combines with acidic water H2 catalyst. There you are getting RCH2OH, one type of alcohol, and you are getting the mixture of alcohols. Okay students, so this way students you are getting two types of alcohols. Example, here students, ester, this side one alkoxy group, that is ethoxy group I have taken students instead of alkoxy, and here it is ethyl C2H5. Now what happens students in presence of lithium aluminum hydride and acidic water? So it will form, see here students, HOH. Now here students, it will form, first it will form propyl alcohol, and other here you will find ethyl alcohol, that is C2H5OH. Understanding students? So here this group will convert into propyl alcohol, this is C2H5, and other will convert into ethanol. So N propyl you are getting propyl alcohol, and here you are getting ethyl alcohol. Okay students, these are very important students. We are going to prepare alcohol is from addition of Grignard reagent with aldehydes or ketone. Preparation of alcohol from addition of Grignard reagent with aldehyde or ketone. Grignard reagent reacts with aldehyde or ketone to form adduct. First there will be addition reaction and to form the adduct, which on hydrolysis with dilute acid gives corresponding alcohols. Okay students, so this way students you can write in general aldehyde and ketone both are containing carbonyl group. So carbonyl group you can also show like this. This is the in general students aldehyde and ketone. Here the it will be delta negative and this will be a delta positive charge. And this is the aldehyde or ketone students. What will happen students, it will react with Grignard reagent that we are showing with RMGX. We are showing with RMGX. Here the magnesium is delta positive and these two are delta negative charges. Now first they will, in presence of dry ether, the addition reaction is always takes place in presence of dry ether. Carbon-carbon double bond with oxygen is becoming single bond like this. Okay students, I need to form, here it will give break and there is a formation of OMGX. Okay students, this is unstable product students. In general I have taken, this is the adduct. This adduct students on acidic hydrolysis. On acidic hydrolysis that we are showing with like this students, which will gives you H and OH. So what happens students, this OH, H will combine, it will form alcohol. It will gives you corresponding alcohol like this. And there is a formation of MgEX and hydroxyl. So this is general students, how carbonyl is converted into alcohol using the Grignard reagent. This is Grignard reagent students. So if carbonyl, whether it is aldehyde or ketone, it is converted into what? Its corresponding alcohol. This is very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.